Ever since the dawn of human consciousness, we have been captivated by one profound and enduring mystery as we gazed at the heavens. Where is the very center of all existence? This journey will guide you through that very question, examining it with the tools of modern science, and exploring theories and discoveries that are poised to fundamentally alter your perception of the cosmos. From the earliest civilizations, humanity has looked toward the sky with a sense of awe, seeing every celestial body, from stars to comets, as a key to deciphering the world. The question of a cosmic center, however, has long been a source of intense debate for both philosophers and scientists. Was Earth the heart of it all, as the ancient Greeks theorized? Or did everything orbit the sun? A revolutionary idea proposed by Renaissance astronomers. This fundamental disagreement has steered the course of our scientific exploration for centuries. Pinpointing the universe's center is far more than an exercise in satisfying curiosity. It's a crucial step toward understanding the fundamental architecture of the cosmos itself. The existence of a center would suggest a specific structure, a point around which all things turn. But if no such center exists, we are forced to reevaluate not just our physical location in space, but our very identity as a species within it. Have you ever considered the deep relevance of this question in contemporary cosmology? Its importance is rooted in the way our cosmic models directly influence our self-perception and our species' narrative. Science, in its purest form, doesn't just provide answers. It encourages you to challenge your most ingrained beliefs, and each new revelation about the universe has the power to reshape your entire worldview. As we delve deeper into this puzzle, we are confronted by the reality of an expanding universe, which adds a fascinating layer of complexity to the idea of a central point. How can a system expand without a definite origin from which it grows? This paradox compels us to rethink our basic assumptions about space and time. You can visualize the universe as a balloon being inflated. While all points on its surface move apart, there is no single spot on the balloon that serves as the center of the expansion. It's truly remarkable how misleading the concept of a center can be. While a circle in geometry has a clear middle, the universe might be better understood as the surface of a sphere, where no single point is more significant than any other. This perspective invites you to move beyond the simple models you may have learned in school, reminding us that the most profound truths are often revealed not through equations, but through analogies that help us grasp the unseen. Throughout its history, the field of cosmology has been marked by unexpected turns and startling discoveries. This relentless search for a cosmic center has motivated generations of scientists to map the heavens, construct powerful telescopes, and dispatch probes into the void. Each advancement has brought us closer to understanding our origins, yet every step forward unveils new questions that cast doubt on our previous conclusions, suggesting we may have been looking in the wrong place all along. Beyond the science, the notion of a center brings forth significant philosophical questions. If the universe has no focal point, does this imply our profound isolation? Or does it mean we are integrated into something far greater than ourselves? Cosmology is not merely the study of celestial objects. It is an exploration into the nature of being and meaning, where every discovery offers a fresh lens through which to view our own existence. There is something incredibly freeing in the idea of a centerless cosmos. In a universe without a primary point of reference, every one of us assumes a meaningful role within a vast, interconnected web of matter and energy. The quest for the center can therefore be seen as a powerful metaphor for our own search for purpose. Rather than fixating on a single, definitive answer, perhaps we should learn to embrace the journey and the inherent wonder of uncertainty. As our scientific capabilities evolve, so too does our comprehension of the universe's true nature. Modern cosmology has unveiled a cosmos that is incredibly dynamic, brimming with mystery and wonder. Each new finding compels us to revise our theories and to conceive of reality in ways previously unimaginable, suggesting that the question of a universal center is merely the gateway to a far more profound investigation. So, where does that leave us in our search for the center of the universe? It may be that the answer itself is less important than the simple fact that we are here, endowed with the capacity to explore and to learn. Each of us is a spectator in this grand cosmic drama, and even if we never locate a definitive center, it is the exhilarating process of discovery that truly defines us. This innate drive for answers is what fuels our curiosity and our desire to comprehend our place in the cosmos. As we conclude this part of our journey, I encourage you to take a moment and consider what the universe signifies to you, how you feel connected to its vastness, and what mysteries you wish to uncover. Ultimately, every individual has a unique story within this immense cosmic tapestry, and the search for a center is, at its heart, a search for connection, for understanding, and for meaning. From the very beginning, humans have looked at the night sky and asked, what is out there? For ancient peoples, the universe wasn't simply a random assortment of lights, but a direct mirror of their culture, their spirituality, and their worldly knowledge. Contemplating the cosmos was akin to assembling an enormous puzzle, where every piece offered a hint about life and existence. So, what did this cosmic puzzle look like to them? Early civilizations, including the Babylonians and Egyptians, held a view of the universe starkly different from our modern understanding. In their conception, Earth was the unmoving heart of everything, sheltered beneath a great celestial dome. This framework is what we now call the geocentric model, a system that placed our world in a position of ultimate importance, like a monarch upon a throne. It's an amazing thought that for thousands of years, the prevailing belief was that the entire cosmos revolved around us. This Earth-centered model was later championed by influential thinkers such as Aristotle and Ptolemy, who presented it as the most logical explanation for the movements observed in the heavens. According to their theories, the sun and planets traced perfect circles around the Earth, like celestial gears in a divine machine. But this elegant and comforting picture was destined to be shattered when a few brave individuals dared to question everything. Consider the figure of Nicolaus Copernicus, who, during the 15th century, introduced a paradigm-shifting notion that the Earth is not, in fact, the focal point of the universe. He proposed that the sun rightfully occupies this central position. This heliocentric model, while highly controversial at first, sparked a profound shift in how we perceived our own place within the cosmos. Can you imagine the immense resistance he encountered for questioning such a deeply ingrained belief? The decisive confirmation of his theory came from the astronomer Johannes Kepler. Through meticulous study of planetary movements, Kepler uncovered that they travel not in perfect circles, but in elliptical orbits. In doing so, he not only validated Copernicus's work, but also introduced groundbreaking principles of celestial mechanics. It's truly incredible to think that by relinquishing the idea of being the universe's center, we actually began to grasp its mechanics with far greater clarity. However, our cosmic journey didn't stop there. The late 19th century introduced a new and powerful character to this story, the telescope. This instrument gave astronomers the ability to peer much deeper into space than ever before, revealing thousands of previously unseen stars and galaxies, which drastically broadened our horizons. What if I were to tell you that many of these galaxies are so distant that their light has traveled for millions of years just to reach your eyes. This realization transformed the concept of the universe from a confined, limited area into an immense stellar ocean, making the idea of an infinite cosmos increasingly plausible. So, how do all of these celestial bodies arrange themselves within such an enormous expanse? The answer proved to be significantly more intricate than anyone had anticipated. It turned out that galaxies aren't just scattered about at random. They are organized into a grand structure that scientists have named the cosmic web. You can picture this web as a vast, interconnected fabric woven from filaments of matter, with galaxies clumping together in groups along these threads, which act as pathways linking them across the universe. By the time we entered the 20th century, it became increasingly clear that the universe likely has no center at all, which raised profound questions about our search for one. This idea was reinforced by the concept of an expanding universe, which was put forth by Edwin Hubble. He observed that all galaxies are moving away from one another, much like dots on the surface of an inflating balloon. It's an amazing thought. Rather than everything revolving around a single point, the entire fabric of the universe is continuously stretching outward. When you gaze up at the night sky, it's easy to feel a sense of order and harmony in the cosmos. The reality, however, is that you are looking at a colossal stage where energy and matter are distributed in extraordinarily complex patterns. Despite this, the desire to find a center continues to occupy our thoughts, prompting the question, are we searching for something that simply doesn't exist? Our understanding has progressed from ancient Earth-centered beliefs to a modern view of an ever-expanding cosmos, with each step taking us further from the notion of a fixed central point. The unresolved question of a center forces us to reconsider our own existence and our relationship with the vast universe that envelops us. This journey through space and time has revealed that the cosmos is far more than a simple collection of stars. It's a domain brimming with mysteries and marvels that still await discovery. So, our exploration is far from over. This very concept of an expanding universe compels you to rethink not just our cosmic knowledge, but also your own place within it all. Now, what if I told you that the universe is not a static object, but is, in fact, in perpetual motion? This might seem like an astounding claim, but it's precisely what scientists have concluded from painstaking observations and brilliant theories. Our journey to this understanding really gained momentum in the 1920s with the work of an astronomer named Edwin Hubble. While studying distant galaxies through his telescope, he noticed a peculiar pattern. The further a galaxy was from us, the faster it appeared to be receding. This crucial relationship, which is now known as Hubble's law, provided a vital clue about the fundamental nature of the cosmos. To help you visualize this, imagine you're blowing up a balloon with small ink dots drawn on its surface. As the balloon inflates, you'll see all the dots move away from each other. In this analogy, each dot is a galaxy, and the balloon's surface is space itself. This is exactly what we observe happening in our universe, leading to the discovery that space is not only expanding, but is doing so at an accelerating rate. Naturally, this raises the question of what force is driving this cosmic expansion. The answer to that question eventually leads us to the Big Bang, the very moment when everything is thought to have begun. It's vital to grasp, however, that the universe doesn't expand like a conventional object from a central point. Instead, every single point in the universe effectively behaves as its own center of expansion. While this might sound perplexing, it is a cornerstone for understanding how the universe operates on the largest scales. This revelation of an expanding universe has prompted scientists to create highly complex mathematical models. But the core idea has profound consequences for how we interpret cosmic history. If we could rewind time, we could envision a moment when all of existence was concentrated into a single, infinitesimal point. Yet, there is no specific location in our current universe that we can identify as that original center. Instead, everything was compressed into an incredibly dense and hot state, and that has significant implications for what it means for us to be here at all. The expansion of the universe is more than just a large-scale event. It actively influences the structure of galaxies, the arrangement of matter, and, by extension, your place in the cosmos. In this cosmic dynamic, gravity plays a pivotal role. You can think of gravity as the force that binds our galaxies, while the universe's expansion continually works to push them apart. This delicate equilibrium is fundamental to comprehending the organization of the cosmos, as there are regions where gravity dominates, causing galaxies to group into massive clusters and superclusters. In other expanses of space, the outward push is far more significant, sending galaxies hurtling away from each other at incredible velocities. This cosmic ballet is as perplexing as it is beautiful, often leaving you with more questions than answers. A truly captivating element of this expansion is how the light from receding galaxies shifts toward the red end of the spectrum. This phenomenon, which is known as redshift, is analogous to the way a train's whistle sounds lower in pitch as it pulls away from you. In this case, light from distant galaxies stretches to longer wavelengths, confirming they are moving away. Yet, despite its conceptual simplicity, the universe's expansion is shrouded in mystery, raising a profound question. What force is driving this acceleration? Many scientists theorize that an unknown agent called dark energy, which constitutes a vast portion of the universe's energy budget, is responsible. The nature of dark energy, and how you might better understand it, remains one of the greatest challenges in modern cosmology. This entire concept invites you to reconsider your own position within the grand cosmic scheme. As you move beyond an Earth-centric perspective, you start to perceive yourself as part of a vast and dynamic system, which challenges you to question not only the mechanics of the universe, but also the meaning of your own existence within it. The expansion offers a unique lens through which to view time and space, revealing that our history is a narrative of continuous change and transformation. In this sense, expansion is not merely a physical process. It becomes a metaphor for evolution and growth, both in the cosmos and in our own lives. Ultimately, the expansion of the universe is more than a scientific theory. It's a powerful reminder of the wonder and enigma that surround us. As you gaze at the night sky, you might wonder what other secrets the cosmos will unveil as our exploration continues. This brings us to a foundational inquiry that has captivated thinkers for centuries. What is the origin of the universe? At the core of this mystery is the Big Bang model, which theorizes that a colossal explosion gave birth to everything you know. To better grasp the Big Bang, I find it useful to imagine the universe as the surface of a balloon. As you inflate it, any points drawn on that surface will move farther away from each other. In this analogy, the balloon's surface is the universe, and the points represent galaxies. Initially, this balloon was entirely deflated, with all matter and energy concentrated into a point of infinite smallness and density. This notion of an expanding universe emerged from the work of Edwin Hubble, who in the early 20th century observed that galaxies were receding from us, leading to the inescapable conclusion that they must have once been much closer together. If you accept the Big Bang as the beginning of everything, the question of how it happened becomes even more compelling. The theory proposes that at the instant of its creation, the universe was a ferociously hot and dense soup of subatomic particles in a state of utter chaos. As it expanded, it began to cool, which allowed these particles to combine and form the first atoms, predominantly hydrogen and helium. You can visualize this process as being similar to making a smoothie. At first, all the ingredients are jumbled together, but as they blend, they find their own space, much like how matter began to organize into more complex structures. As the universe continued its outward journey, these clouds of gas started to coalesce under the influence of gravity, eventually forming the first stars and galaxies. One of the most mind-bending aspects of the Big Bang is that it didn't just create matter. It also brought space and time into existence. This means that before this event, time as you understand it simply did not exist. The answer to the question, what was there before the Big Bang, is a perplexing one. There was no before, because time itself was born in that moment. This expansion also led to other remarkable phenomena, such as the formation of the cosmic microwave background, a faint thermal radiation that permeates the entire universe. This echo of the Big Bang, which you can still detect today, serves as a sort of fingerprint from the moment of creation, providing scientists with invaluable clues about the initial conditions of the cosmos. Of course, the Big Bang theory does not exist without its share of debate, and you might reasonably wonder if it is the only possible explanation for the origin of the universe, or if other models could also account for what we observe. Despite any remaining uncertainties, the cumulative evidence from both observation and experimentation provides powerful backing for the Big Bang theory. While we haven't solved every puzzle, the data is compelling. This theory does more than just explain the universe's origins. It also presents us with profound new inquiries. For instance, what is the long-term evolutionary path for galaxies? Is the universe destined to expand indefinitely, or will it eventually halt and begin to collapse back on itself? These very questions define the exciting field of cosmology, where researchers dedicate themselves to decoding the universe's deepest secrets. It's truly remarkable to consider that every one of us, every individual, star, and planet, is fundamentally a consequence of that initial moment of the Big Bang. We are literally built from the same elements that were created in the universe's first stages, which means we are all intrinsically woven into this vast cosmic tale. Investigating the Big Bang also compels you to reflect on the very nature of science in our quest for understanding. Through continuous research and discovery, we've developed a framework that gives us a way to grasp our own existence. Yet the universe steadfastly remains a place brimming with mysteries, where each answer we uncover typically reveals a host of new questions. In this light, the Big Bang signifies not merely a beginning, but an unending voyage of discovery that inspires us to keep searching for our true place in the cosmos. Einstein's theory of relativity stands as one of those ideas that might seem overwhelmingly complex initially, but it ultimately provides a completely new lens through which to view the world around you. What if I told you that space and time are not the fixed, unchanging concepts you perceive them to be, but can actually warp depending on your motion? This revolutionary thought was brought to us by the one and only Albert Einstein, a man who forever altered our grasp of physics. Let's first examine our everyday perception of time, which we typically see as a consistent, forward-moving line. However, Einstein's work reveals that time can actually stretch or shrink based on how fast you are moving. If you were to travel at a velocity approaching the speed of light, you would find that time passes differently for you than it does for your friends back on Earth. This mind-bending effect is known as time dilation, and it remains one of the most astonishing predictions of relativity. Relativity also completely redefines our understanding of gravity. Rather than envisioning gravity as a simple force pulling objects downward, Einstein conceived of it as the curvature of space-time, the unified fabric of space and time. Imagine a vast, taut sheet of rubber. If you were to place a heavy bowling ball on it, the sheet would sag and create a depression. A nearby marble would then naturally roll into that dip, not because of a mysterious pull, but because it's following the curve. This is precisely how gravity functions on a cosmic scale. This raises a fascinating point. How does this new perspective on gravity alter our view of the universe? Relativity demonstrates that light itself must follow the contours of curved space. When light from a distant star passes by a massive object, its path is bent. This phenomenon, which we call gravitational lensing, can act like a natural telescope, allowing us to see celestial objects that would otherwise be completely obscured from our view, sometimes creating distorted or even multiple images of a single distant star. This theory isn't just for understanding the cosmos. It has tangible applications in our daily lives. Were you aware that Global Positioning System, or GPS, technology is fundamentally dependent on relativity to function correctly? The satellites orbiting Earth are moving at immense speeds and experience weaker gravity, causing their internal clocks to tick at a slightly slower rate, different rate than ours on the ground. Without constant adjustments for these relativistic effects, your mapping applications would become wildly inaccurate within minutes. To dig a little deeper, it's helpful to know that the theory is composed of two main parts. The first, special relativity, concerns itself with objects moving at constant speeds. The second, general relativity, incorporates gravity and its profound effects on the fabric of space-time. A fundamental principle of special relativity is that nothing can travel faster than the speed of light. This isn't just a technological hurdle. It's a fundamental speed limit imposed on the entire universe. General relativity, however, is what truly transforms our view of the cosmos, leading us to see the universe as a dynamic and interconnected entity. This concept aligns perfectly with the Big Bang theory. If space itself is expanding, then time must be expanding right along with it. This brings you to a completely new way of thinking about the universe's past and future, framing it as an ongoing journey that has been unfolding for 13.8 billion years and is nowhere near its end. When you think of the universe as a fabric in constant motion, it helps you visualize how matter and energy interact on a grand scale. Relativity suggests that everything is deeply connected. Every star, every galaxy, and every atom in your own body is a participant in this incredible cosmic dance of space and time. It's as if we are all members of a grand orchestra, where every single note and instrument plays a vital role in the overarching symphony of the universe. Perhaps the most exhilarating question that emerges from relativity is this: if time can truly stretch and compress, what does that imply about our perception of reality itself? If time is not an absolute constant, could it be theoretically possible to travel through it? While science fiction has long explored this idea, for now, the theory of relativity has given us far more questions than answers on the true nature of time, forever changing our understanding of the universe and opening doors to a world of endless possibilities. This theory has compelled us to reconsider concepts once held as absolute and to push into new frontiers of physics. Every breakthrough rooted in its principles brings us a step closer to comprehending the vast and enigmatic cosmos we call home. So when you think about relativity, it's vital to recognize that it's about more than just abstract formulas. It embodies our innate human desire for knowledge and our struggle to understand our place in this immense universe. This entire endeavor reminds us that even though we may feel insignificant in the cosmic expanse, our capacity for curiosity and questioning is what defines us as a species. Relativity is not simply a scientific theory. It represents a profound journey toward grasping what it truly means to exist within this constantly evolving reality. The very geometry of the universe is a captivating subject that fundamentally challenges our perception of the cosmos. Have you ever paused to wonder what shape the universe might actually possess? For many, the notion that the universe has a definite shape can seem bizarre, yet it stands as a cornerstone of modern cosmology. Scientists primarily investigate three potential configurations: a flat, a closed, or an open geometry. Each of these models has deep and far-reaching implications for the ultimate fate and fundamental structure of our universe. Let's first consider a flat universe, a concept that is likely the most straightforward to envision. Imagine an infinitely extending sheet of paper where parallel lines will never cross and light travels in unwavering straight lines. A flat universe implies that the density of its matter and energy is perfectly balanced at the critical density required to counteract gravity's pull. This equilibrium suggests that the universe's expansion will continue forever into the distant future, though it will do so at a progressively slowing rate. Conversely, a closed universal geometry is akin to the surface of a sphere. If you were to walk in a straight line across such a surface, you would eventually find yourself back at your starting point without ever changing direction. In a closed universe, gravity is dominant enough to eventually halt cosmic expansion and pull everything back together, suggesting a future where all of existence could reconverge into a single, infinitesimal point. The model of an open universe is perhaps even more fascinating. You can picture this geometry as being shaped like a saddle, where two parallel lines will inevitably diverge. In this configuration, the density of matter falls below the critical value, which means that the universal expansion will not only persist, but will actually accelerate over an infinite timescale. This acceleration is believed to be driven by dark energy, a mysterious force pushing the cosmos apart. So, what does any of this actually mean for us and our place in the universe? One of the most compelling questions that arises from these geometric possibilities is how the shape of the cosmos influences our perception of it. Whether we inhabit a flat, closed, or open universe, this underlying structure affects not only the universe's destiny, but also our fundamental experience of space and time. The pivotal question then becomes, how can we possibly determine which geometry accurately describes our reality? This is where precise astronomical observation becomes essential. Scientists employ powerful telescopes and instruments to meticulously map the distribution of galaxies and analyze the cosmic microwave background, which is the faint afterglow of the Big Bang. By studying this data, they can deduce the overall shape of the universe, piecing together a cosmic puzzle. As we delve deeper, another possibility emerges. What if the universe's geometry isn't one of these pure forms, but rather a more intricate combination? Contemplating a universe that blends elements from all three models is a mind-bending exercise that pushes the limits of our comprehension. If the universe is flat, we might be living in an infinite expanse. If it is closed, we could be part of a finite, interconnected system, while an open universe suggests a future of unstoppable expansion. As we explore these possibilities, it's crucial to understand that the geometry of the universe isn't merely an academic debate. It carries profound implications for the nature of time, space, and matter itself. It compels us to ask not just what the universe is like, but how we are fundamentally connected to its structure. The search for these answers guides us into truly uncharted territory, as scientists continue to develop advanced technologies to unravel these cosmic mysteries. Ultimately, contemplating the universe's geometry offers a window into the unknown, urging us to think beyond our daily experiences and appreciate the immensity that surrounds us. By exploring these grand ideas, we not only gain knowledge about the cosmos, but also reflect upon our own existence within it. So, The next time you gaze at the night sky, ask yourself what the shape of the universe might be, and what that could mean for all of us. The quest for cosmic knowledge is, in the end, a search for ourselves. To understand this better, we must ask, what is critical density, and why is it so fundamental to our comprehension of the universe? The helpful way to start is to picture the universe as a vast balloon. As we inflate this balloon, its expansion can vary. It might stretch out so far that its surface becomes weak, or it could maintain a firm and compact form. Critical density serves as the pivotal threshold that dictates the ultimate fate of our expanding universe. Should the cosmos contain matter exceeding this value, its expansion could eventually halt and reverse, causing it to contract much like a deflating balloon. Conversely, if the density is lower than this critical point, the universe is destined for perpetual expansion, inflating endlessly without pause. In the finely tuned scenario where the density perfectly matches the critical value, the universe will expand forever, but its pace will continuously slow, as if it were taking a single, unending breath. To grasp this concept, you can think of a simple analogy involving balloons at a party. If you have more people blowing than there are balloons, some will inevitably pop or deflate from the pressure. However, with the perfect ratio of people to balloons, everyone can be properly inflated and held in a state of equilibrium. In cosmic terms, critical density is that ideal number, settling the question of whether the universe will ultimately collapse or continue its expansion indefinitely. Yet, this value isn't static. It dynamically shifts based on the universe's rate of expansion and its total content of matter and energy. Scientists have estimated the current critical density to be about equivalent to a certain quantity of matter and energy within each cubic meter of space. So, how do we figure out if our reality is above, below, or precisely at this tipping point? The answer comes from the detailed observations and calculations of astronomers. By employing powerful telescopes and satellites, researchers can measure all the visible matter, like stars and galaxies, and also account for dark matter, which, though unseen, reveals its presence through its gravitational pull. Combining this information allows them to approximate the universe's overall density. This leads to one of the most compelling questions. What is the consequence if the universe's total density falls short of the critical mark? Such a reality would imply an endless expansion, culminating in a cold, desolate future, where galaxies grow ever more distant, until only darkness and silence remain. On the other hand, if the total density surpasses the critical threshold, a completely different destiny awaits. You can envision a universe that starts to collapse inward, with galaxies hurtling toward each other, eventually colliding in a spectacular conclusion known as the Big Crunch. And in that perfect middle ground, the universe would expand eternally, always slowing but never stopping, maintaining a delicate dance between outward momentum and the inward tug of gravity. More recently, a new factor has been introduced into this cosmic calculation: dark energy. This enigmatic force appears to be accelerating the universe's expansion, adding a profound layer of complexity to our models of critical density. Although we know dark energy makes up a large part of the universe's total density, its precise relationship with the critical threshold remains poorly understood. This also raises another captivating query. Could the critical density itself evolve over time? As the cosmos expands, its material composition might change, and the influence of dark energy could shift, presenting cosmologists with a fascinating puzzle and suggesting we may be on the verge of a new paradigm in our cosmic understanding. Critical density, therefore, is far more than a simple number. It is a conceptual boundary that frames our entire understanding of the universe's destiny. It serves as a powerful reminder that nature often rests on a precarious balance, where even the slightest variations can trigger immense and irreversible consequences. This idea naturally encourages you to ponder your own place within this grand cosmic scheme. If you see the universe as an inflating balloon, it makes you wonder what part we play in its vast and intricate existence. Ultimately, critical density stands as a foundational principle in cosmology, providing a framework for us to investigate the deepest questions about the universe's structure and fate. From the mechanics of its expansion to its potential conclusion, the concept invites you to perceive the cosmos not merely as a physical realm, but as a continuously unfolding enigma we are still striving to solve. As we push forward in our search for answers, it's important to recognize that each new discovery moves us closer to comprehending not just the universe, but our own significance within it. Within the boundless fabric of the universe, we encounter a boundary that appears to define the limits of our knowledge. This boundary is known as the cosmic horizon. But what exactly is it, and what makes it so significant? To help you visualize this, think of the universe as an expanding bubble or an inflating balloon. As it grows larger, any 2 points you marked on its surface will steadily move apart from each other. In this analogy, the cosmic horizon represents the absolute edge of what we can possibly see and learn from our unique position here on Earth. A fascinating question naturally follows. Why are we unable to see what lies beyond this horizon? The explanation is found in the speed of light. Although light moves at an astonishing velocity, the sheer scale of the universe means that light from certain regions has not yet had enough time to reach us since the cosmos began. This implies that there are vast stretches of space that are fundamentally inaccessible to our observation, simply because their light is still on its way. It is a captivating thought that entire sections of our universe remain a complete and utter mystery to us. The cosmic horizon is also inextricably linked to the concept of time. When you gaze at a distant star, you are not seeing it as it is now, but as it was in the past. If a star is 1,000 light-years away, the light reaching your eyes tonight started its journey 1,000 years ago. Therefore, every glance toward the heavens is a look back through time. This raises a profound dilemma. For any galaxy whose light has not yet crossed our horizon, we can never know its present state. We are left to wonder what exists beyond our view. Could there be other galaxies, different forms of life, or perhaps even entirely different realities? As you grasp the concept of the cosmic horizon, you inevitably encounter the equally compelling idea of universal expansion. The continuous expansion of the universe means our own cosmic horizon is also growing, suggesting that, with enough time, we might glimpse ever more distant regions. This brings up a fascinating question. Does this expansion have a limit? Is it possible that in the far future, objects now within our view will slip back beyond the horizon, lost to us forever? The notion of the cosmos engaging in a grand game of hide and seek with us is both profoundly exciting and deeply unsettling. When you consider the nature of this horizon, it's crucial to understand that it is not a static or rigid boundary. As the universe stretches, galaxies currently perched on the edge of what we can see may one day enter our field of vision. However, this possibility hinges entirely on the rate of cosmic expansion. Should this expansion accelerate, certain galaxies will retreat from us with such incredible velocity that their light will never have the chance to reach us, making them permanently unobservable. It's a staggering thought that the universe is in perpetual flux, transforming and evolving this very moment. The cosmic horizon also carries significant philosophical weight. What does it truly mean to accept that there is a fundamental boundary to what we can observe in the universe? This limitation compels you to contemplate your own place within the cosmos, to challenge your sense of importance, and to reflect on your role in a seemingly endless cosmic drama. This boundary on our perceptions serves as a powerful reminder that despite our scientific advancements, a vast amount remains unknown and perhaps unknowable. Moreover, the concept of the cosmic horizon clarifies why certain areas of the universe are more challenging to investigate than others. The regions that lie beyond this boundary are effectively hidden from us, which complicates any effort to create a complete map of the cosmos. This introduces the captivating possibility that we inhabit a small pocket of space within a much larger, more intricate universe. You might even wonder if other intelligent civilizations, in different corners of the cosmos, are wrestling with the very same dilemma, unable to see past their own local horizons. With ongoing progress in technology and science, astronomers are devising clever ways to deduce what exists beyond our cosmic horizon. By analyzing cosmic microwave background radiation, often called relic radiation, and employing other sophisticated methods, scientists are starting to piece together clues about the universe we cannot see directly. Still, these deductions are essentially educated hypotheses, built upon very limited information. You have to ask, is it conceivable that we might one day break through the barriers of our horizon and finally learn what lies on the other side? The quest for these answers is the very engine of human curiosity. Ultimately, the cosmic horizon is far more than a theoretical abstraction. It is directly tied to our unending search for knowledge. It reminds you that science is not a destination, but a constantly evolving journey where each new discovery sparks new inquiries and every answer reveals new pathways to explore. In this light, the cosmic horizon stands as a symbol of our inherent curiosity and our profound desire to venture into the unknown. As you continue to contemplate the cosmos, never forget that while our vision has limits, our imagination does not. The cosmic horizon is an invitation to keep questioning, keep searching, and never cease to be awed by the mysteries of the universe. Have you ever sensed that there's something mysterious out in the cosmos, something invisible that nevertheless shapes everything we see? This feeling gets to the heart of dark matter, one of the most compelling and elusive components of the cosmic puzzle. Although you cannot see or touch it, scientists are convinced of its existence and its critical role in the universe's structure. But what exactly is this dark matter, and what makes it so fundamentally important? To better understand dark matter, it helps to use an analogy. Imagine you are at a party in a large room filled with people, but significant portions of the room appear empty. Despite this, you can feel that the space is more crowded than it looks. That's because there are unseen individuals whose presence affects the entire atmosphere of the room. In much the same way, dark matter is that invisible presence influencing the behavior of galaxies and all the visible matter that we can observe. The first suspicions about this mysterious substance arose among astronomers back in the 1930s. While observing the movement of galaxies, they detected something peculiar. Stars on the outer edges of galaxies were moving at speeds far greater than their calculations predicted. How was this possible? Based on visible matter alone, these galaxies should have torn themselves apart, yet they remained perfectly intact. This observation led to an incredible conclusion. There must be something else out there, something unseen, that possesses mass and exerts a powerful gravitational pull. Because dark matter does not emit any light, it remains undetectable by our telescopes, which makes it extraordinarily difficult to study directly. Nevertheless, its presence is clearly felt through its gravitational influence on the surrounding cosmos. Imagine the challenge of trying to uncover something you can't see. That is precisely the task facing physicists and astronomers. They rely on intricate mathematical models and observations of galactic motion to infer its existence, engaging in a kind of cosmic game of hide and seek. To give you a sense of scale, Current estimates suggest that roughly 95% of the universe is composed of dark matter and dark energy. In contrast, only about 5% is made of the ordinary matter you're familiar with, the substance of stars, planets, and galaxies. It is truly astonishing to consider that we are surrounded by such an immense quantity of matter that we are completely unable to detect through conventional means. One of the most widely accepted theories regarding the nature of dark matter proposes that it is made of subatomic particles that do not interact with ordinary matter, except through the force of gravity. These hypothetical particles are referred to as WIMPs, which stands for weakly interacting massive particles. Although their existence has not yet been experimentally confirmed, scientists across the globe are working tirelessly to detect them. Imagine being the first person to discover the key that could unlock one of the deepest secrets of the universe. That is, the motivation behind the global search for dark matter. Around the world, scientists are engaged in a monumental search for these enigmatic particles, utilizing everything from underground laboratories and particle collision experiments to dedicated observatories. Every time a new clue emerges from this research, the global scientific community watches with anticipation, following a cosmic thriller where each new chapter introduces an unexpected turn in the plot.
You might wonder why understanding dark matter is so critical. The answer is tied to its profound influence on the very architecture of our universe. Without dark matter, galaxies as we know them simply could not have taken shape. Picture the cosmos as an immense tapestry. Dark matter serves as the essential thread weaving it all together, providing the foundational structure upon which stars and planets can form.
Furthermore, dark matter is a key player in the expansion of the universe. While the cosmos continues to grow, dark matter provides a gravitational counterbalance that tempers this expansion. This dynamic helps us to probe the ultimate destiny of everything. Will the universe expand indefinitely, or will it one day halt its growth and begin to contract? The solution to this question may hinge on the precise quantity of dark matter that exists. Scientists have used computer simulations to visualize a universe devoid of dark matter, and the outcomes are truly startling. These models reveal that galaxies would group together in completely different ways, creating a cosmos that would be unrecognizable to us. This powerful thought experiment underscores just how vital dark matter is in sculpting the universe we inhabit today. So the next time you gaze up at the night sky, remember that what you can see is only a fraction of what's truly out there. The luminous stars and familiar constellations represent just a minor part of a vast and intricate cosmic stage. Although it remains unseen, dark matter is the fundamental scaffold supporting the very existence of everything visible to us. It's remarkable to contemplate the profound mysteries still waiting to be solved. As our exploration of the cosmos presses forward, dark matter will undoubtedly stay at the forefront of scientific inquiry. Researchers are relentlessly pursuing answers, and each breakthrough moves us a bit closer to deciphering the fundamental secrets of the universe. The truth about dark matter has the potential to completely reshape our comprehension of reality, and perhaps one day we will finally be able to perceive what is currently invisible. The search for dark matter serves as a powerful reminder that, while much remains unknown, every question we pose brings us nearer to a deeper understanding of our own place in the cosmos. But did you know that the universe isn't just expanding, but is also being propelled by an unseen force? This phenomenon is attributed to what we call dark energy, and although we can neither see nor touch it, its effect on the cosmos is enormous. To help you visualize its impact, think of the universe as a balloon that is constantly being inflated. Dark energy is the very air that fills it and drives its expansion. In the absence of this energy, the cosmos would behave in a completely different manner. But what exactly is dark energy? And why is its study so essential to our grasp of the universe? It constitutes approximately 70% of the total mass energy content of the cosmos. Yet despite its overwhelming presence, it remains one of the greatest puzzles in cosmology. Scientists across the globe are dedicated to studying this force, but its secrets have proven to be exceptionally difficult to uncover. You might ask why, if it's so dominant, we know so little about it. The challenge lies in dark energy's intrinsic nature. It seems to be a passive component of the universe, one that doesn't actively interact with matter in a way we can easily detect. So how did we arrive at the conclusion that this mysterious energy even exists? The story begins in 1998, when two separate teams of astronomers were observing supernovae in distant galaxies. By analyzing the light from these cosmic explosions, they discovered something extraordinary. Galaxies are not just receding from one another, but they are doing so at an accelerating rate. This was a revolutionary finding. Up until that point, the prevailing belief was that the collective gravity of all matter in the universe should be slowing the expansion down. Instead, it appeared some kind of repulsive force was actively pushing the cosmos apart. This discovery not only reshaped our view of the universe, but also prompted the development of the theory of dark energy. To put it another way, imagine you throw a ball into the air. You would expect gravity to pull it back to the ground. Now, what if a powerful gust of wind caught the ball, pushing it higher and higher despite gravity's pull? Dark energy functions in a similar fashion, overpowering the gravitational attraction of matter and accelerating the expansion of space itself. Even with its profound influence, the true nature of dark energy is still an open question. Is it a type of energy inherent to empty space, or could it be a fundamental property of space-time itself? Several theories exist, but none have been conclusively proven. Some scientists propose that dark energy is a constant, an unchanging value that functions like a form of anti-gravity, while other theories suggest it might change over cosmic time, adding another layer of complexity to our understanding. It is truly mind-boggling to consider that in a universe so vast and magnificent, such a subtle and invisible force can wield such overarching dominance. If we return to the balloon analogy, with the universe expanding, dark energy is the air filling it up. This means that as the universe gets larger, the influence of dark energy becomes an even more significant driver of its expansion. How then can we possibly study something that we cannot directly observe or measure? Scientists have devised clever tools and methodologies to probe the effects of dark energy. One primary method involves observing the large-scale structure of the universe. By mapping how galaxies cluster and interact, researchers can deduce the influence of this mysterious force. They also rely on advanced telescopes and ambitious space missions, like the European Space Agency's Euclid satellite, which is designed to map the distribution of matter and help unravel the secrets of dark energy. Finally, what does dark energy mean for our distant future? If this force continues to dominate the cosmic landscape, we may be heading toward a future where galaxies drift so far from one another that they become utterly isolated in the vastness of space. This theoretical end state is often referred to as the Big Freeze, a scenario where the universe grows cold, dark, and empty. Conversely, if dark energy is not a constant, a different future could unfold in which the universe's expansion halts and then reverses, culminating in an event known as the Big Crunch. While these are fascinating possibilities, we currently lack the definitive evidence to confirm them. The search for an understanding of dark energy transcends mere scientific inquiry. It ventures into the realm of philosophy, prompting us to consider what it means for our own existence if the cosmos is governed by a force we cannot comprehend, and how we find our place within this ever-changing, expanding reality. As our scientific capabilities grow, an increasing amount of effort is being channeled into solving the puzzle of dark energy. It is possible that in the future we will uncover the solutions to these profound questions, thereby gaining a much clearer picture of our universe's structure and behavior. Dark energy stands as a powerful reminder that, for all our progress, an immense amount remains to be discovered and understood within the vast cosmos that envelops us. So the next time you gaze up at the night sky, take a moment to remember the invisible forces shaping everything you see. Dark energy is more than just a critical ingredient of the universe. It embodies the very essence of human curiosity and our relentless ambition to grasp the unknown. In this profound journey of discovery, each new insight into dark energy moves us closer to resolving the most fundamental questions about the cosmos and our role within it. Have you ever stopped to consider the large-scale organization of the universe? The immense expanse of the cosmos isn't simply a random scattering of stars and planets. It is structured like a colossal cosmic web that stretches for billions of light years. Within this intricate network, galaxies are not haphazardly placed, but are arranged into complex formations that narrate the entire history of the universe itself. So, what exactly is this large-scale structure? I want you to picture the universe as a gigantic spider web, where every point where the threads cross represents a galaxy. These galaxies are not isolated. They are tethered together by long filaments of dark matter, which serve as invisible highways connecting them. In this way, the universe is a place where galaxies gather into groups, and those groups assemble into superclusters, weaving a magnificent cosmic fabric. How did we first come to understand that the universe possesses this intricate design? Through careful observation of the heavens, astronomers began to identify incredible patterns in the cosmos. If you examine a map of the universe on its grandest scale, you will see that galaxies are not distributed uniformly. Instead, they congregate in massive structures, separated by enormous, empty regions, sometimes referred to as cosmic voids, a layout that directly reflects the story of matter and energy from the Big Bang until today. This leads us to the next logical question. What is gravity's role in this grand design? Gravity is the fundamental force that binds all of this matter together. Each galaxy, with its immense collection of stars and planets, exerts a gravitational influence on its neighbors. You can think of it like a dance, where your movements affect your partners. In the same way, galaxies pull on one another, moving and clustering to create even larger structures, a cosmic ballet that can sometimes become chaotic, leading to galactic collisions and mergers that spark the birth of new stars and solar systems. And what part does dark matter play in this scenario? Though we cannot see it directly, we know dark matter exists due to its gravitational effects, and it is a crucial component in shaping the universe's structure. It is thought to constitute about 85% of all matter in the cosmos, and its pervasive presence provides the gravitational anchor that holds galaxies together within their clusters. Astronomers have observed that dark matter itself forms a vast network that dictates the distribution of all the visible matter we can see. You can imagine this cosmic web as a landscape carved out by rivers, where the dark matter acts like the water, shaping the terrain of the universe and creating the structures we observe. In fact, studies confirm that galaxies tend to form and align along these dense filaments, where the pull of gravity is at its strongest. As we delve into these cosmic formations, it's truly humbling to contemplate the scale of what we are trying to understand, as the distances involved are almost beyond human comprehension. When we discuss clusters of galaxies, we are referring to assemblages that can contain hundreds or even thousands of individual galaxies, all bound together in one region.
These massive structures are formed through a process of gravitational collapse, where matter clumps together over billions of years, creating regions of incredibly high density. However, it's crucial to remember that the universe's expansion is not perfectly uniform. Some regions are expanding more rapidly than others. This variation can set the stage for fascinating interactions between galaxies in the distant future, and some research suggests that we might even witness massive galactic collisions many billions of years from now. The cosmic web is anything but static. Much like a living organism, it evolves continuously over time. Over cosmic timescales, gravitational forces relentlessly sculpt the universe as galaxies cluster, collide, and merge, while new stars and solar systems are born from this perpetual celestial dance. The organization of matter across the cosmos not only reveals its history, but also holds clues to the ultimate fate of the universe. By deepening our understanding of these structures, we can begin to speculate on how the cosmos will evolve, whether it will expand forever, or if gravity will one day triumph and pull everything back together. Ultimately, it is vital to consider what all of this implies for us as human beings. We are an infinitesimally small part of this sprawling cosmic web, a tiny bubble of matter and energy adrift in the immense fabric of the universe. Each new discovery about this structure brings us closer to understanding not just how the universe is today, but the long and incredible journey it took to get here. Every star you can identify in the night sky, along with every galaxy we can detect, serves as a testament to the staggering complexity and elegance of all creation. As we strive to comprehend the cosmos, we are not just unraveling the secrets of the universe, but also discovering our own significance within it. It's a common experience to gaze up at the stars and feel humbled by the sheer scale of everything. And this feeling is precisely what leads us to a crucial concept for making sense of it all: the cosmological principle. At its core, this principle posits that on the largest of scales, the universe is both homogeneous and isotropic. But what does that practically mean for you and me? To grasp this, visualize drawing countless dots on the surface of a balloon. As you inflate it, all the dots move farther apart from one another, yet no single dot can be identified as the absolute center of the expansion. This is a powerful analogy for the universe itself, suggesting there is no central point from which everything is expanding outward. While this idea can be difficult to grasp, its implications for cosmology are profound. Homogeneity means that if you could sample a sufficiently large volume of the universe, you would find that matter and energy are spread out quite evenly. This might seem to contradict what we see, where galaxies gather in dense clusters, leaving vast voids of empty space. However, when your perspective zooms out to encompass immense cosmic distances, these local irregularities dissolve, revealing a remarkably uniform distribution. And what of isotropy? This concept describes the observation that the universe appears fundamentally the same regardless of the direction in which you look. The powerful implication here is that there is no privileged or special location anywhere in the cosmos. Much like being a guest in a perfectly circular room, your view is consistent no matter where you stand. This idea is foundational because it confirms that you are not at the center of existence, but rather an integral part of an enormous, interconnected whole. Naturally, this principle raises some fascinating questions for scientists. How does a uniform universe account for theories proposing unique cosmic structures, or even entire regions where the laws of physics might operate differently? These are precisely the lines of inquiry that researchers are actively pursuing. Although some theories propose the existence of local variations, the cosmological principle remains the bedrock of our current cosmic model, supported by powerful observational evidence,
most notably the cosmic microwave background, the afterglow of the Big Bang, which is found to be almost perfectly uniform across the entire sky.
So why is this uniformity so important? It provides the foundation upon which we build cosmological models that can accurately predict the universe's behavior and trace its evolution. The notion of a homogeneous cosmos also means that its history is a shared one, not dependent on any single location. You could think of it like a grand historical book where every page is equally vital to the overall narrative, with no single character or place being the central focus. In this way, the story of the universe becomes a collective epic. Despite this large-scale evenness, the universe is brimming with astounding details, from galaxies and stars to individual planets. These complex structures, which appear so chaotic up close, all conform to this overarching principle when viewed as a single system. This balance, however, pushes us to wonder about what exists beyond the horizon of our observable universe, in regions we may never see due to cosmic expansion. Our innate curiosity drives us to find answers, and it's possible that future discoveries related to dark matter and dark energy will cause us to refine our understanding of cosmic homogeneity and isotropy. From a more philosophical standpoint, the cosmological principle encourages a deep reflection on your place in the universe. If there is no center, and we are all part of a vast, undifferentiated whole, what does that imply about our own existence? Perhaps there is a certain freedom in recognizing that we are threads in a much larger cosmic fabric, not merely isolated observers. Ultimately, this principle serves as a constant reminder that for every answer we find, countless new mysteries wait to be discovered in the ever-expanding cosmos. Now, let's explore an idea that is as captivating as it is mind-bending: the multiverse. What if I were to tell you that the universe you inhabit might be just one of a countless, perhaps infinite, number of others? This concept, suggesting the existence of separate universes, each with its own physical laws and unique history, forces us to completely reconsider our position in reality. To help you visualize this, imagine our universe as a single bubble floating in a cosmic ocean filled with innumerable other bubbles, each a universe unto itself and entirely separate from the rest. This image is not just visually stunning. It prompts us to ask deep questions about the very fabric of reality. You might wonder what it signifies to exist in a single universe within a vast sea of possibilities. The multiverse theory isn't merely a concept from science fiction. It has been a subject of intense debate among philosophers and scientists for decades. Some interpretations of quantum mechanics propose that every choice you make could potentially split reality, giving rise to an entirely new universe. Think of it like a storybook, where you can select different paths to various endings. Each of your choices could be unfolding as a complete narrative in a separate cosmos. Have you ever considered the sheer number of universes that might be generated from the countless decisions we all make each day? One of the most compelling arguments for the multiverse stems from cosmic inflation, a theory suggesting the universe underwent a period of incredible, rapid expansion just after the Big Bang. This exponential growth could have sectioned off distinct pockets of space, each evolving into its own independent universe, making ours just one of many. What are the consequences of this for our perception of time and space? And if other universes do exist, how does that alter our quest for meaning about life and our own existence? The concept of a multiverse also fundamentally challenges our idea of being unique. Within an infinite ocean of universes, the specialness of our own reality could seem to evaporate. However, this same idea might also bring a sense of comfort. If there are other realities where circumstances are different, perhaps you can find hope in the thought that worlds exist without the problems we face, where happiness and peace are the prevailing state.
Science typically demands concrete proof, but when it comes to the multiverse, tangible evidence might be forever out of reach if these universes are truly separate from our own. How could you ever possibly observe or measure them? This raises a compelling question. Could the effects of these other universes, while unseen, still exert some influence on our reality? The connections between them might be far more subtle than we currently imagine. Of course, not everyone subscribes to the multiverse hypothesis. Some scientists maintain that without any direct evidence, it remains pure speculation. But isn't the scientific endeavor at its core a constant exploration of the unknown? Delving into the multiverse concept compels us to push the limits of our knowledge and stay receptive to new possibilities. So, should you consider the multiverse a credible idea, even if we lack the means to prove it right now? If the multiverse is indeed real, our understanding of life's meaning could shift dramatically. In a reality where every potential outcome of your choices is realized somewhere, what does your freedom truly signify? Are you genuinely making choices, or are your actions simply playing out across a vast, pre-existing network of possibilities? Furthermore, the existence of a multiverse would have a profound impact on our search for extraterrestrial life. If innumerable other universes are out there, what are the odds that some of these worlds also harbor life? You could be contemplating civilizations that we can never encounter, yet they might be so advanced that they would shatter our current definitions of life and technology. Finally, the multiverse invites you to reflect on what reality itself truly is. Is your perception of life in this universe the only valid one? The notion that we are part of an infinite collection of universes raises fundamental questions about our identity, purpose, and existence. This makes the multiverse theory not just a scientifically fascinating idea, but also a reflection of our own deepest hopes and fears. It challenges you to explore the unknown, to question what you accept as true, and to envision a cosmos far more expansive than you can immediately grasp. Have you ever found yourself thinking about whether the universe has a center? This captivating idea has intrigued philosophers, scientists, and thinkers for all of human history. Many of us were brought up with the idea that there's a central point to the vastness of space, a singular location from which everything else expands. To begin unraveling this cosmic puzzle, let's first consider how ancient civilizations perceived the cosmos. For many centuries, the prevailing belief was that Earth was the center of everything. This geocentric model gave us a sense of importance, positioning humanity at the very heart of creation. With time, of course, we discovered that the sun holds the central position in our solar system, which in turn moves among the countless stars of the Milky Way galaxy. Yet, this still leaves the bigger question. If Earth isn't the center, then what is? The answer might not be what you expect. As astronomers started to map the expansion of the universe, they came to realize there is no single fixed point from which everything is moving away. You can visualize this by imagining a balloon being inflated. As it fills with air, every spot on its surface gets farther away from every other spot. In this analogy, the surface of the balloon represents our universe, and you can see there is no center on that surface. Every point is receding from all others simultaneously. This understanding is supported by the Big Bang theory, which describes the origin of the universe approximately 13.8 billion years ago. While everything we know was once compressed into an infinitesimally small point, from the moment of its origin, the universe began to expand. Instead of there being a fixed middle, we find ourselves in a cosmos that grows uniformly in every direction. Every galaxy is moving away from us, just as it is moving away from every other galaxy. When you look out into the night sky, everything appears to be in motion. Yet there is no specific place you can identify as the absolute center of it all. From any vantage point in the cosmos, an observer would witness every other galaxy receding, which generates a convincing illusion that their specific location is the very center of it all. This immediately brings up another fascinating question. If no true center exists, does that diminish our importance in the grand scheme of the universe? Many assume that lacking a central point relegates us to being just an insignificant speck in a boundless cosmic sea. However, that perspective isn't quite accurate. Each one of us is an integral part of a cosmos that is in a perpetual state of transformation and growth. Your existence holds just as much weight as that of any distant star or galaxy. Furthermore, the concept of a centerless universe challenges our philosophical assumptions about where we fit in. What does it truly mean to be human in a cosmos without any single focal point? There is a certain freedom in realizing that no location is specially favored, and that life and matter can emerge anywhere within this vast expanse. This realization also compels us to re-examine our beliefs about meaning and purpose. Some might ask if it's possible, even without a physical center, to locate the very heart of the universe. This is less a scientific query and more a poetic one, inviting you to contemplate the profound interconnectedness of everything. Stars, planets, and galaxies are all threads in an immense cosmic tapestry, where each element has its own distinct role and position. We inhabit a universe that never ceases to astonish us, and as our telescopes and technology improve, we learn more about its fundamental nature. Theories suggesting a multiverse, a hypothetical collection of other universes with unique physical laws, imply that the idea of a center could be far more intricate than we imagine. In our quest for a cosmic center, we've discovered dark matter and dark energy, mysterious components that are fundamental to the universe's structure. Yet even they do not point to a single, static location. Instead, they reveal a cosmos that is dynamic and enigmatic, a realm where the questions we ask are often more significant than the answers we find. The deeper you delve into these inquiries, the clearer it becomes that the universe is far more than an empty void. It is a stage where human curiosity has fueled incredible discoveries. Every glance at the night sky serves as a potent reminder that you are part of something immeasurably larger than yourself, an expanding cosmos where the very notion of a center defies our conventional understanding. Ultimately, the question of the universe's center is an invitation to explore, to question, and to be filled with wonder. In this immense and mysterious creation, the truth is that you are not isolated. Every star, galaxy, and particle is in constant motion, and perhaps that is what truly matters. Not finding a center, but embracing our part in this magnificent cosmic journey. What if I were to tell you that we possess tools that let us gaze into the past and comprehend how our universe was born? Telescopes have been absolutely vital in this pursuit of knowledge. Since antiquity, we have stared at the stars and pondered what might exist beyond our world. But the arrival of modern technology has enabled us to probe these celestial enigmas with unprecedented depth. You can think of telescopes as enormous eyes that allow us to gaze deep into the fabric of space. Through them, we've managed to capture light from stars that are millions of light years away. This light, which might appear as a simple twinkle in the sky, is essentially a time capsule, carrying with it the stories of the universe's distant past. But how exactly does that work? Consider a lighthouse on a distant shore. When you observe its beam, you're not just seeing a point of light. That light has journeyed through space to reach you, conveying information about its origin and distance. In much the same way, when we capture the light from a faraway galaxy, We are actually seeing that galaxy as it appeared billions of years ago. It's analogous to getting a letter from a friend on another continent that describes their life as it was in the past. The first great shift in our observation of the cosmos occurred with Galileo's telescope in the 15th century. Until then, the prevailing belief was that Earth was the center of everything. By observing the moons of Jupiter and the rings of Saturn, Galileo demonstrated that there was a great deal more happening beyond our own planet. But what if I told you that was just the very beginning of the story? The development of far more powerful instruments like the Hubble Space Telescope has exponentially increased our observational power. Hubble has given us views of galaxies in the process of forming, and stars being born and dying, unveiling phenomena that were previously beyond imagination. Did you know that because of this telescope, we have managed to see galaxies located more than 13 billion light-years from us? This means we are witnessing light that has been traveling almost since the moment of the Big Bang. Every image delivered by these advanced telescopes serves as a reminder of just how expansive and perplexing the universe is. However, mere observation is not sufficient. We must also interpret what we are seeing. This is where data analysis becomes crucial, as scientists study the captured images and light to deduce the composition, age, and motion of celestial bodies. They are like cosmic detectives, meticulously searching for clues embedded in the light that reaches us. It isn't just waves of light that carry these cosmic stories. Telescopes designed to detect radio waves and infrared radiation have also broadened our comprehension of the universe. The cosmic microwave background radiation, often described as the echo of the Big Bang, was found thanks to instruments capable of capturing these specific wavelengths. This radiation is a faint static that permeates all of space, a lingering remnant from the instant that everything began. Isn't that an incredible thought? Additionally, some telescopes are now tasked with searching other worlds for exoplanets, planets that orbit stars other than our Sun. A few of these remarkable instruments can even analyze the atmospheres of these distant planets, searching for telltale signs of life. This, of course, brings us to one of the most profound questions of all. Are we truly alone in the universe? With every new observation, we move a step closer to a potential answer, made possible as technology has advanced enough to position our telescopes beyond Earth's atmosphere. The images of space we now receive possess an unprecedented level of clarity and detail. Instruments such as the James Webb Space Telescope are engineered to detect infrared light, which allows them to peer through obscuring clouds of gas and cosmic dust to uncover hidden secrets. Just think about the extraordinary discoveries that await us with these sophisticated new tools. The combined capabilities of all these telescopes have completely revolutionized our perspective on the universe. We've shifted from viewing the cosmos as a static, unchanging expanse to seeing it as a dynamic and perpetually evolving place. You can see evidence of this in the observation that galaxies are moving apart, a finding that supports the theory of an ever-expanding universe. Every new observation compels us to re-examine our existing knowledge and to pose entirely new questions. At the same time, you must understand that not everything we observe is immediately apparent. Concepts like dark matter and dark energy have arisen from our observations. Although they are invisible to us, their effects on the cosmos are undeniable. Telescopes have revealed that the universe possesses a complexity far beyond our wildest imaginations. With each technological leap, these instruments become silent chroniclers of cosmic history. They demonstrate that even though you are a tiny component of this vast cosmos, every question you ask and every answer you find brings you closer to comprehending your place within it. The pursuit of knowledge is a journey without an end, and each image captured represents another stride toward understanding who we are and where we originate. So the next time you gaze up at the star-filled sky, consider that every glimmer of light holds a story yet to be unveiled. Each star, every galaxy, and each twinkle in the cosmic darkness serves as a testament to the marvel of our universe, leaving you to wonder what profound mystery our telescopes will unravel next.
Gravity stands as one of the universe's fundamental forces, and its reach is far more profound than you might initially assume. But how does this unseen force sculpt the very architecture of the cosmos? The answer to that question is truly captivating, guiding us on an exploration through the limitless domains of space and time. When you think about gravity, your mind often connects it to everyday earthly experiences, like an apple detaching from a tree or the sensation of your own body weight. Yet, on a cosmic scale, gravity is the master architect of the universe itself. Picture an immense canvas filled with stars, planets, and galaxies. Gravity is the brush that connects these elements, crafting a magnificent cosmic work of art. Galaxies are not solitary islands adrift in the void. They are engaged in constant interaction with one another. The gravitational pull between them creates a kind of cosmic ballet, where each galaxy's movements influence the others. Larger galaxies function like powerful magnets, drawing smaller ones toward them, and thereby defining the structure of galactic groups and clusters. However, gravity's influence isn't limited to attraction. It can also orchestrate breathtaking collisions. When two galaxies merge, the compression of gas and dust from the impact can ignite the formation of new stars. This process is a powerful reminder that the universe is in a state of constant flux, with gravity as the primary agent of these transformations.
And what about black holes? These enigmatic objects serve as the ultimate testament to gravity's immense power. They are born when a massive star depletes its fuel, causing its core to collapse under its own gravitational force. The resulting objects are so incredibly dense that nothing, not even light, can escape their pull, and they play a vital role by shaping the motion of nearby stars. Gravity also provides a crucial framework for understanding the universe's expansion. As the fabric of space stretches, galaxies drift farther apart from each other, but you might wonder why they don't all separate at a uniform speed. The reason is gravity, which continues to exert its attractive force, holding galaxies together within their local clusters in a delicate equilibrium with cosmic expansion. As you explore the universe further, you encounter astonishing formations like the cosmic web, which illustrates how matter is organized on the largest scales. This intricate network is composed of filaments of galaxies that crisscross through space, forming vast voids and dense clusters. Gravity is the master weaver of this tapestry, guiding the formation of these structures and ensuring the universe is an organized system rather than a chaotic one. Have you ever considered what the universe might look like if gravity were different? A weaker or stronger gravitational force would result in a completely unrecognizable cosmos. It's possible galaxies would never have formed, or they might have immediately collapsed in on themselves. The very stability of the universe as you know it is contingent upon this fundamental force and its precise interaction with matter. It's easy to forget that gravity isn't just an earthly phenomenon. It is the very same force that locks planets into orbits around the sun and moons around their planets. It is the reason stars don't just disperse into empty space, but instead congregate into the majestic structures we call galaxies. In essence, gravity is the fundamental force that binds the entire cosmos together. Despite its pervasive influence, gravity still holds its share of mysteries. Certain aspects of it remain beyond our current comprehension. For instance, the intricate relationship between gravity and dark energy, the force accelerating the universe's expansion, continues to be a profound puzzle for scientists. How do these two opposing forces interplay within the grand cosmic design? As our scientific understanding progresses, researchers are continually devising new theories and experiments to unlock these secrets. Gravity remains an exhilarating and dynamic area of research, one that consistently presents new surprises and challenges our existing models. In the end, the influence of gravity transcends the purely physical, carrying with it deep philosophical implications that touch upon our very understanding of existence. This perspective invites you to consider your place in the cosmos and your profound interconnection with everything that exists. The force of gravity not only anchors you to the Earth, but also links you to distant stars and galaxies, serving as a constant reminder that you are part of a much grander design. Ultimately, gravity is far more than a mere physical force. It is the very essence that sculpts our universe, enabling our understanding of galactic organization, stellar behavior, and the overall evolution of the cosmos. As you delve into the universe's secrets, gravity stands as a steadfast companion on this voyage of discovery, the unifying thread that ties together every element of our existence in this immense and enigmatic reality. Over the last several decades, modern cosmology has grown impressively, evolving into a captivating discipline where scientific rigor and human curiosity merge. But what exactly is meant by modern cosmology? To grasp this, you must first explore a fundamental question. How has our view of the universe been transformed in recent times? A key factor that has completely reshaped our comprehension is the new ability to observe the cosmos across a wide array of wavelength ranges. We are no longer confined to the narrow band of visible light. Now, you can investigate cosmic phenomena using X-rays, microwaves, and radio waves. This expanded vision allows you to witness events that were once entirely invisible, such as the cosmic microwave background, the faint afterglow of the Big Bang, which is essentially the residual thermal radiation that permeates all of space. Picture a boundless ocean of information, where each type of wave represents a distinct ripple, conveying a unique story about the universe. One of the most thrilling accomplishments stemming from this has been the confirmation of dark energy's existence. Through meticulous observations of how galaxies are receding from one another, scientists found that the universe's expansion is actually accelerating. This discovery prompted a fascinating question. What is this enigmatic energy that drives the accelerating expansion? While the answer is still unknown, the very confirmation of its existence marks a monumental leap in our understanding. Another domain that has witnessed remarkable progress is our knowledge of dark matter. Although you cannot see dark matter directly, its gravitational influence is unmistakable. By analyzing the behavior of galaxies and galaxy clusters, scientists have successfully inferred its presence, much like how you can observe the current of a river by watching the leaves and debris it carries along, even if the water itself is clear. A more recent development that has truly sparked the imagination is the concept of the multiverse. This theory proposes that our universe might be just one among many, each governed by its own distinct physical laws and characteristics. This raises profound questions. If an infinite number of universes exist, what does that imply for our definition of reality? Could there be alternate versions of you living out different lives in these other realms? This idea challenges not only the foundations of physics, but also the very way you perceive existence itself. Within this framework, the cosmological principle has gained renewed importance. This principle posits that, on the largest scales, the universe is both homogeneous and isotropic, meaning it looks roughly the same everywhere and in every direction. For you, This implies that while your corner of the cosmos might feel special, it fundamentally adheres to the same physical laws that operate throughout the universe. However, the observable variations in large-scale structures and matter distribution serve as a reminder that this uniformity is not absolute. Computer simulations have also assumed a pivotal role in the advancement of modern cosmology. These powerful models enable scientists to recreate the evolution of the universe from the Big Bang to the present day, serving as a kind of virtual laboratory where you can witness the interplay of matter and energy over billions of years. These simulations have yielded incredibly precise insights into the formation of galaxies and the intricate structure of the cosmic web that connects them. Furthermore, the study of gravitational waves has inaugurated a completely new era in our exploration of the universe. These ripples in the fabric of space-time, created by cataclysmic events like the merging of black holes, provide an entirely new method for observing cosmic phenomena. Imagine having the ability to listen to the universe, not just look at it. This auditory perspective is leading to discoveries that were once considered beyond our reach. Yet for all this progress, a great many questions remain unresolved. Will we ever truly comprehend the nature of dark energy? What is the precise role of gravity in the universe's expansion? It seems that each answer we find only serves to unlock a new set of questions, which is what makes cosmological research such an exhilarating and ever-changing field. The quest to understand the universe is a journey in perpetual motion, where every new discovery compels you to reconsider what you know and to venture further into the unknown. Modern cosmology doesn't just aim to provide answers. It seeks to kindle curiosity and a sense of wonder in all of us. As you continue this exploration, it's vital to remember that science is fundamentally a collaborative endeavor. The breakthroughs in cosmology are the cumulative result of tireless work by thousands of scientists across the globe, with each one contributing a crucial piece to the vast cosmic puzzle. The search for solutions to the deepest mysteries of the universe is a unified human effort that knows no borders. Ultimately, modern cosmology is about more than just understanding the cosmos you inhabit. It's about recognizing your own place within it. Every finding brings you a step closer to the essence of what it means to be human, and to our connection with the immense universe that surrounds us. So, what lies ahead in this unending search? Only time will reveal the answer, but one thing is certain. You are merely at the dawn of an incredibly exciting journey. The very notion of a universal center raises compelling questions about our existence, but the absence of a central point can be profoundly liberating. It suggests you are not aimlessly adrift in a sea of stars, but are instead an integral part of a boundless and ever-evolving whole. You are not just an isolated point floating in an endless void. Rather, you are an integral piece of a colossal cosmic web, woven into the fabric of everything that surrounds you. When you contemplate the fundamental nature of reality, you face an intriguing paradox. What does it signify for the universe to lack a center? So much of your daily life is defined by central points, from the comfort of your home to the bustling core of a city. But in the cosmos, this familiar structure does not exist. To grasp this, think of the universe as an ever-inflating balloon, where every point on its surface recedes from all others as it expands. This is precisely how the cosmos operates, with every galaxy drifting away from us, just as we drift away from them, participating in a grand, unified celestial ballet. This notion of a centerless universe forces you to completely reevaluate your own position and perspective within it. If no central point exists, then how do you find your place or establish a sense of belonging? The answer lies in the connections that bind everything together. Every celestial body, from stars to galaxies, and every particle of matter is a component of a much larger interconnected system. Forces like gravity and flows of energy unite us, creating the intricate and complex structures that define our universe, fostering a powerful sense of a cosmic community. Contemplating a universe with no single focal point carries profound philosophical weight, presenting you with the reality that you are a product of cosmic evolution, a tiny fragment within an immense network. This realization might initially make you feel insignificant, but it can equally serve as a source of immense inspiration. The absence of a center acts as a constant reminder that you are an explorer on a boundless voyage of discovery. On this journey, you are far from alone, as every person and every new piece of knowledge contributes to the unfolding epic of the cosmos. This prompts you to consider your own role in this vast expanse, and to ask whether your existence matters without a central reference point. The answer, I believe, is an emphatic yes, because each of us possesses the unique ability to witness, comprehend, and be moved by the sheer magnificence of it all. Fueled by your innate curiosity and creativity, humanity has engineered powerful telescopes and interstellar craft, pushing past the boundaries of our immediate world to unravel the universe's deepest secrets. As you venture further from our home planet, you discover that each new insight simply reveals more questions about what lies beyond our current understanding. This relentless search for answers becomes your driving force, propelling you forward even as the very idea of a cosmic center dissolves. Your curiosity acts as a compass, guiding you through the immense darkness of space. Still, the concept of a centerless reality can be disquieting, particularly in a world where you often search for clear direction and meaning. Yet, if you look closer at this apparent chaos, you can discern a hidden, underlying order. The fundamental laws of physics and the intricate dance between particles and galaxies all point to a profound equilibrium that governs this cosmic complexity. This quest for understanding inevitably leads to deeper questions about your own existence, forcing you to ponder what it means to be human in such an expansive and often impersonal universe. Perhaps the simplest answer is that your very impulse to comprehend the cosmos is what gives your existence meaning. The fact that you question, explore, and dream is a powerful testament to the singular nature of our species. This idea of a universe lacking a center also encourages you to appreciate the shared human experience. Despite all our cultural and individual differences, we all inhabit the same small blue world spinning in a vast expanse of darkness. You are bound together by a common curiosity, a thirst for knowledge, and an unwavering pursuit of answers. In this way, the universe becomes a mirror, reflecting both our greatest aspirations and our deepest fears. With every scientific breakthrough in fields like relativity, quantum physics, and modern cosmology, you are given new tools to investigate the nature of reality. The ultimate challenge, however, is not just in acquiring this knowledge, but in integrating it into your daily life. The real question is how you can use these cosmic insights to foster a deeper connection with your environment and with one another. Ultimately, the universe's lack of a center is not a sign of meaninglessness. Instead, it is an invitation for you to create your own. Each of us has the capacity to be a source of light in the infinite darkness, illuminating the way for those who follow. By finding purpose within what may seem like a chaotic cosmos, you can generate a positive influence that ripples through your community and across the world. When you reflect on the absence of a universal center, you are naturally led to a state of humility, realizing you are a small part of an immeasurable whole. This acknowledgement can be incredibly liberating, offering you the chance to look beyond yourself, nurture empathy, and collaborate toward a shared, brighter future. So, while the cosmos may not have a center, your own life certainly does, found in the connections you forge, the stories you tell, and the dreams you chase together. This leads to another compelling question. Could other universes exist in addition to our own? The possibility of a multiverse has long fascinated scientists and philosophers, fundamentally challenging our perception of the cosmos. But it's important to understand what this theory truly entails and what it implies about the fabric of reality. If other universes do exist, what might they be like? Are they near-perfect copies of our own, or could they be governed by entirely different physical laws and principles? The concept of multiple universes raises these profound questions, compelling you to delve into the captivating and mysterious idea of the multiverse. One helpful way to visualize the multiverse is by imagining a colossal library, where each book on the shelves represents a distinct universe with its own unique narrative, characters, and set of rules. While some of these books might tell a story remarkably similar to our own reality, others could be unimaginably alien. According to this theory, your universe is just a single volume among an infinite collection, and scientists have developed several theoretical frameworks to support this very idea. Among the most prominent theories is the many worlds interpretation of quantum mechanics. This concept suggests that every time the universe faces a quantum choice, it splits, realizing all potential outcomes in separate realities. Essentially, this means that for every decision you've made, another version of you exists in a parallel universe who made a different choice, perhaps pursuing an entirely different life. The central question, however, remains: how could we ever scientifically verify that these other worlds actually exist? Another compelling idea originates from the theory of cosmic inflation, which describes a period of explosive expansion just moments after the Big Bang. During this phase, it's theorized that distinct pockets or bubbles of space could have formed, each evolving into a self-contained universe. You can picture them like soap bubbles in an ever-growing foam, some isolated and others perhaps colliding. Each of these bubbles could possess its own unique set of physical laws and constants, giving rise to an incredibly diverse multiverse. Yet, the multiverse concept is far more than a simple theoretical diversion. It carries profound implications for how we perceive our own existence. If an infinite number of universes truly do exist, what does that signify for us? Are our lives merely echoes in a sea of alternate realities? Or do our choices hold unique weight in this immense cosmos? Such questions compel us to deeply consider our position in the grand scheme of things and the very fabric of reality itself. The quest for concrete evidence of other universes presents a monumental scientific challenge. Since observation and experimentation are the cornerstones of science, we face the problem of how to perceive anything beyond the confines of our own cosmos. Some physicists propose that we might find faint traces of other universes imprinted on the cosmic microwave background, the ancient afterglow of the Big Bang. But determining whether these are genuine signals or just statistical anomalies is an enormous hurdle. This leads directly to the problem of falsifiability, a key principle in science which states that any valid theory must be capable of being proven false. The multiverse hypothesis struggles here, as it's difficult to imagine an experiment that could definitively disprove the existence of universes we can't observe. This very issue ignites fierce debate, with some scientists arguing the multiverse is more philosophy than physics, while others maintain that its explanatory power makes it a worthwhile pursuit despite the difficulties.
The philosophical dimensions of the multiverse are just as captivating. If there is an endless array of universes, it could mean that every conceivable story has already played out somewhere. Does that suggest that every one of your aspirations and dreams is a reality in another world? This notion that our existence is but a single thread in an infinite tapestry can feel both incredibly liberating and profoundly unsettling, forcing us to ask whether our choices truly matter in an endless ocean of possibilities. The multiverse also forces us to confront fundamental questions about creation itself. If countless universes exist, what or who is responsible for them? This line of inquiry can lead to contemplation about a creator or forces far beyond our current comprehension. We're left to wonder if the multiverse is simply a product of cosmic chance, or if there is some grander design behind its immense scale. This theory also has practical applications in physics, potentially holding the key to unifying quantum mechanics and general relativity, and could even offer new insights into mysteries like dark matter and dark energy. Looking ahead in the field of cosmology, the multiverse is certain to remain a vital area of debate and investigation. As our theories evolve and new technologies emerge, we might discover unforeseen methods for testing the existence of other universes. Driven by an insatiable curiosity, humanity constantly pushes against the boundaries of the known, and this intellectual journey invites us to question the nature of our own reality. The exploration of the multiverse could very well become one of modern science's greatest endeavors, with each step potentially bringing us closer to understanding the ultimate truth. Have you ever found yourself searching for a central point, a place that gives you your bearings? In our everyday lives, we rely on reference points to orient ourselves, but this instinct breaks down when we consider the universe on a cosmic scale. After exploring this question, we arrive at a startling conclusion. The universe may not have a center at all. Imagine the universe as the surface of an expanding balloon. As you inflate it, every point on its surface moves away from every other point. In this model, you cannot identify any single spot as the center of the expansion. Instead, every point is equivalent. The cosmos appears to operate in much the same way. Since every galaxy is receding from every other, no location holds a privileged central position. This realization fundamentally changes our understanding of our own place in the cosmos. For centuries, we viewed Earth as the center of all things, but science has revealed that we reside in a quiet corner of a galaxy that is just one among billions. This shift in perspective is crucial. We are not the focal point of creation, but rather observers on a vast cosmic stage, where every star and galaxy performs its part in a grand unfolding drama. And what of the universe's expansion? This discovery stands as one of the most thrilling revelations in the history of cosmology. When the astronomer Edwin Hubble observed that galaxies are moving away from us in all directions, he unveiled a universe that is not static and eternal, but dynamic and evolving. You can think of it like a loaf of raisin bread baking in an oven. As the dough rises, all the raisins move farther apart from each other, not because they are moving through the dough, but because the dough itself is expanding. This is the fundamental nature of our universe. It is continuously expanding, and this expansion forces us to rethink our entire concept of a central point. The very substance of everything you know is made of matter and energy, yet the cosmos is dominated by components we are only beginning to grasp. I'm referring to dark matter, which acts as the invisible scaffolding holding galaxies together, and dark energy, the enigmatic force that seems to be speeding up this cosmic expansion. These mysterious forces serve as a humbling reminder that, despite all our scientific achievements, a vast territory of the unknown still awaits our discovery.
As you contemplate this search for a center, it inevitably leads to profound questions about your own existence. If no such point exists, does that render us insignificant? On the contrary, it offers you a truly unique perspective, showing that each of us is a vital thread in an immense cosmic tapestry that weaves through all of space and time. Your actions, your thoughts, and your feelings all create ripples in the universe, regardless of how minor they may seem. The concepts we have examined are not merely scientifically intriguing, they also carry immense philosophical weight. The lack of a cosmic center compels you to question your identity and your place in the grand order of things. Are you truly alone in this seemingly infinite expanse? The multiverse theory speculates that other universes might exist, each with its own set of rules and realities, opening up countless possibilities that challenge your current grasp of existence. As you've seen, modern cosmology provides a constantly shifting portrait of reality. With every new observation and breakthrough, a fresh set of questions emerges before us. This suggests that perhaps the entire quest for a center isn't the most important goal. Maybe the true essence lies within the spirit of curiosity itself, as every question you ask brings you a step closer to understanding, and every answer only reveals new mysteries to be solved. This journey of discovery is far from complete. Science is always evolving, and as it does, so do our ideas about the cosmos and our role within it. It is our innate human curiosity that serves as the engine propelling scientists and thinkers to push the boundaries of knowledge. When you look up at the star-filled sky, let every galaxy and every point of light be a reminder of all that is still left to be uncovered. In the end, the idea of a center of the universe, while fascinating, is likely nothing more than a mirage. Instead of seeking one specific point, I believe you should embrace the boundless nature of the cosmos and the endless mysteries it holds. The universe's profound beauty is rooted in its complexity and the infinite potential it presents to you. Ultimately, you are an integral part of a greater whole, and each of us has our own unique place in this spectacular cosmic design. So, the next time you gaze up at the night sky, remember this. While there may be no single center, every star shines with its own individual light. In much the same way, each and every one of you plays a unique and irreplaceable role in the magnificent, ongoing story of the universe.